Yeah, I guess just all of them so far,
Okay.
except for the...
Yeah, if you know how to do them, then we don't need to go over it. But 8 to the 2/3. What does that mean, first of all?
Um, 8 to the 2/3. It just
Means the
I
cube
get a
root.
negative number, right?
No, it means the cube root of 8 squared. The numerator acts as the same thing as if you said 8 squared,
Oh, yeah.
and the denominator acts as the root. Now, usually when you do these, you want to do the root first. So what's the cube root of 8?
2.
So it's the same as 2 squared, or 4.
Okay.
Okay. Now, the next one is the 5th root of 32 to the minus 2. So what's minus 2 mean? The exponent of negative 2.
What does it,
How can I rewrite this?
oh, the reciprocal, so it would be
There you go.
to the half, or to the...
Well, it's still 2, but it becomes a positive 2 when you put it in the denominator. So it would be this way.
Oh, yeah.
In other words, this is equal to that. Now we just have to work with the denominator. What's the 5th root of 32?
2.
2 squared.
4.
So that whole expression is equal to 1/4.
All right.
Okay. The next one says 81 to the 1/4. Is that right?
Yeah.
So what does that mean? Or what's the answer?
4th root of 81, which is, is it 4?
No?
I don't remember what the square root of...
No, you know it's going to be a small whole number. So it's either going to be 2, 3, 4, one of those.
3.
3. 3 times 3 times 3 times 3 is equal to 81. Same as 9 times 9.
All right.
Okay. All right, inverse functions. If f of x is equal to 3x minus 2 over 4, how do we find the inverse?
For inverse, what do we switch the x and the y? Or?
Yeah, we don't have a y, so instead of f of x, let's say y. Because y and f of x are interchangeable. So now we want to find the inverse of this. So what's the next thing I'm going to write?
X equals 3y minus 2 over 4.
Okay. Now what?
And then we times by 4.
Okay. So we have 4x equals 3y minus 2. Now what?
Then add the 2.
So we have 4x plus 2 equals 3y.
And then just divide it all by 3.
There's your inverse.
Okay.
That's the inverse of that.
Cool.
Now we want to verify that g of x is an inverse of f of x. And if that's true, then f of x is also the inverse of g of x. So how do we determine if these are inverses of one another without doing what we just did. In other words, we could solve for the inverse and get this, but there's another method using the composition of functions that actually defines what inverses are.
I'm not sure.
Okay, the composition function would be f, instead of x, we're going to put g of x in. So if g of x is the inverse of f, this has to be equal to x. Likewise, g of f of x also has to be equal to x. Now, another way you might see this written is fog x. That's the same thing as f of g of x, or goff x, also the same thing as g of f of x.
Okay.
All of these things are the same, but what it tells us is we have to take f of g of x and have it come out to be x. So
Okay.
if f of x equals 2x minus 3, what is f of 2 equal to?
One.
Okay. So we know what to do when we put something other than x in the parentheses. So now what is f of, instead of g of x, I'm going to write what g of x is. So that's the thing that has to be equal to x. What is f of x plus 3 over 2?
Really? It's going to be 2x plus by 6.
Okay, first of all, I'm going to substitute whatever this is in for x.
Yeah.
Okay, and then I'm going to distribute. Well, we don't need to multiply the numerators because the 2's cancel. So now I have x plus 3 minus 3. That's equal to x. That shows it's the inverse.
Oh, okay. Those just cancel out.
Now, I don't know if they want you to do both steps or not. Usually they do. So the next thing we have to do is find out what g of f of x is. So what's this? The second part. Remember, g of x is x plus 3 over 2. So what is g of f of x?
So it would be just be x also.
Well, let's prove it. In other words, g of f of x is the same as g of 2x minus 3. Just substitute what f of x is. And then that's going to be what?
It's going to be 2x plus by 3.
Okay, first of all, wherever we find x, we're going to substitute 2x minus 3. So that's the first thing we did. And then we're going to add 3, and we're going to divide by 2.
Yep.
And this whole thing, the 3's cancel, the 2's cancel,
and then 2's
that's
cancel.
also equal to x. So that proves that g of f of x is also equal to x. Now, I've never actually found a function where if one of them was equal to x, the other one wasn't. But even still, they seem to want you to prove both ways.
Okay.
Okay. Let's see here. I can't move this up. So let's do this. Perform complicated operation. So first
I can do these.
You can do these? Okay.
Yeah, just plugging in the f of x and g of x.
Yeah, and it's pretty much, it's easy to add, and it's pretty easy to subtract, and it's pretty easy to multiply, and it's pretty easy to divide.
Yeah.
Let me just test you on one of them.
All right.
Is this 8x to the what, 1/3?
Yeah, 8x to the 1/3.
So what is 8x to the 1/3 divided by, I want to do f of x over h of x, so 4x to the 2/3. What's that equal to? In other words, that's f of x divided by g of x, or h of x.
Wouldn't it just 2x to the 1/3?
What's 1/3 minus 2/3?
1/3.
Negative 1/3. So it's 2x minus 1/3.
Bigger number.
And we don't want to leave that as the answer. It's kind of like leaving an irrational number in the denominator. We want to write this like this.
Oh, all right.
Okay? So in other words, once you come up with the negative 1/3, that tells you to put the x in the denominator, not the numerator.
Okay.
So let's see. Let's graph this equation. I think I have this problem on the next page, don't I?
Yeah, I think I got one of the problems. I just wanted to do one of the graphing ones because.
Okay, I don't have it on the next page. Unless it's on 17. Yeah, it is. Okay. What's the parent function?
Y equals square root of x minus 1.
No, just square root of x.
Oh, just square root of x.
And let's go straight to the transformations, and then we'll come back and talk about the others.
Okay. Let's see.
Let's graph that first of all.
Okay.
There's y equals square root of x. And we've got three things going on here, or 4 things going on here.
Yeah.
What's the consequences of the negative 1?
You shift right 1.
Shift right by 1. What's the consequences of the plus 3?
Shift up 3.
What's the consequences of the 2? Not the negative 2, but the 2.
Stretch of 2, or vertical stretch of 2.
Vertical stretch of factor of 2. What's the consequences of the negative sign?
Reflection.
About?
The x-axis.
Because you can have a reflection about the y-axis. If that negative sign is inside and in front of the x, then it is a reflection about the y-axis. Okay, so we got 4 things going on here. And whenever you have a reflection, do that first.
Okay.
Because it matters.
All right.
Okay? So the first thing we're going to do is reflect it. And I'm going to do these one at a time. So this is y equal negative square root of x. Okay? Now we're going to move it right 1 and up 2. I'm sorry, up 3. Right 1 and up 3. Well, here's right 1. Here's up 3. So the new vertex would be like this. And this would be y equal, what am I doing? Excuse me.
Yeah.
First of all, we're talking about this curve down here, the dotted line. We're going to move that right 1 and up 3. So it's going to start right there. Not going to change shape. It's going to look exactly the same shape because I haven't done any stretching yet.
Okay.
So this curve is y equal negative square root of x minus 1 plus 3. And finally, we're going to do a vertical stretch of 2.
Okay.
What's the effect of a vertical stretch of 2?
It's going to straighten out more. Or won't it?
Actually, let's see what a vertical stretch of 2 does to our original line. Let's start with y equals square root of x. Let's put some points on there. Now, what would y equal 2 square roots of x look like?
I'll shift each dot up 2 more.
Or twice as far away from the x-axis, right? So that dot would be there. This dot would be way up here. This dot would be off the screen. But the net effect would be to make it look more like this. So it kind of steepens it. Okay, so the last one we had was this blue line. So I'm going to take that blue line and steepen it. Like that. And that is finally y equals minus 2 square root of x minus 1 plus 3. It's not that easy to tell on the square root function whether it's been vertically stretched or not. In other words, if I were to just draw one, and I say to you, has that been vertically stretched? You can't really tell. Because, in other words, maybe that was the original one, and this has been vertically stretched. But it's not apparent from just looking at it. Not like, well, if we're looking at a parabola, y equal x squared, I can tell that's vertically stretched because that's the vertical stretch. It makes it skinnier.
Oh, yeah.
Much easier to tell with a parabola whether there's been a vertical stretch or shrink. But with the square root function or the logarithmic function, not so easy.
So it doesn't change really the shape.
Not really. It does technically, but not noticeable. Okay, so we've got the parent function. Lists the key points in a t-table. What would be one key point?
Let's see. 0.
Well,
Or
can x be 0?
no.
Because then I'd be taking the square root of negative 1. So 0 is not a key point, but x equal 1 is. What is y when x is equal to 1?
It's going to be 3.
What's another key point?
2.
Okay, when x is 2, y is equal to what?
1.
Okay. And I would say the last key point would be x equal 5,
Mm-hmm.
because then y would be -1.
So, yeah.
Actually, probably the key point they're looking for is that makes y equal to 0. In other words, the x-intercept. But that's not a round number, although they're still probably looking for it. But I would have to, that's more difficult to solve. The value for x that makes y equal 0.
Mm-hmm.
It's like 9/4 minus 1, or 9/4 plus 1, something like that. -9/4 plus 1. But anyway, you know how to do that. Okay, what's the domain of this function?
1 to -3.
Can x be, okay, so 1 with a bracket or a parenthesis?
Parentheses, I think. It is a bracket.
It is a bracket because x can be 1. You can take the square root of 0.
Okay.
So that's the domain. Range is always harder to come up with.
All right.
Let's write this function up here again. This takes a little bit of out-of-the-box type thinking. Notice that as x gets bigger, what happens to this part of the function?
Becomes more negative, or
Okay.
it's a higher negative number.
Okay. So, what's the high-end range on this function? If
Negative infinity.
what's as small as this could be? Okay, negative infinity is correct on the left side.
Mm-hmm.
And this could be at best 0. So what's the high side?
3.
And it's a bracket because when x is 1, y is 3. So y can be 3.
Okay.
Okay? But when you approach problems like this and trying to find the range, always try to look at it as what's going to happen to this part as x goes from 1 to infinity. And you can tell that it's just going to keep getting more and more negative like you did, which means the maximum side has to be where this part is the smallest it can possibly be. Well, by that, actually the biggest it can possibly be, which is 0.
Mm-hmm.
This part here can only be 0 on the high end.
Okay.
Okay. What do you want to do next? You got a half hour.
Let's see.
I would suggest we do one more domain and range question on 6.
Yeah, could we? That'd be awesome. All right.
What's the domain on this?
It's going to be -1 would be, I don't know, brackets. Let's see.
Brackets correct, because it can be -1.
Mm-hmm. And that.
As x grows to infinity, what happens to y? I'm sorry, that's not the right question. Can x grow to infinity?
Yeah.
That's the domain.
Okay. All right.
Range.
Let's see.
What's the big end? How big can y be?
-2.
That's how small it could be,
Okay.
right?
It can go to infinity, I guess.
Okay, so the right side of the range is infinity.
Okay.
And the left side, again, we want to know, well, how small can that possibly be? 0. It can never be negative. Let's go back and look at this problem.
Okay.
Go back to the domain. I made a mistake. First of all, let me ask you this. What's that equal to?
-2 or +2.
-2. What's this equal to?
+2.
What's the domain on this function? I'll give you a hint. The first one wasn't correct, nor is the bracket.
-.
You see why? There's nothing wrong with this being negative because we're taking the cube root of it.
Oh,
You're
okay. That makes sense.
odd roots of something. In other words, the domain of this is -infinity to infinity. The domain of this is greater than or equal to 0. Because this is an even root, you can't take even roots of negative numbers, but you can take odd roots. So there's nothing wrong with what's inside the radical being anything. If the domain is -infinity to infinity, what's the range?
Wouldn't it be the same?
Okay. What's the parent function?
Would it be y = cube root x?
Correct. And that it's the reciprocal of this, so it's something like that.
Okay.
That's the parent function. And you'll notice that from the parent function, we can pretty much read the domain and range off the parent function.
Oh, yeah.
Now this goes, x can go all the way to -infinity and to +infinity, and y can go all the way to -infinity and to +infinity. So
Okay.
sometimes if you have trouble with the domain or range, look to the graph and just read it off the graph.
Okay.
Okay?
Yeah, the graph helps a lot.
What kind of transformations are taking place here?
There's a shift left 1 and a shift down 2.
Right. And neither of those shifts change the shape of the curve. Neither one is a stretch or a shrink.
Okay.
All right. Should we look at number 7?
Yeah, could we just do one of those?
Sure.
Just do A.
Yeah.
Okay.
Let's do it item by item. Let's take the number part first. What's the square root of 50 equal to?
Square root of 25 and square root of 2.
Which is 5 root 2.
Yeah.
So there's this part. What's the square root of x to the 5th?
X to the, or X to the 3rd?
No. What we're going to do is we're going to remove as many x squareds as we can. Notice that x to the 5th is the same as x squared times x x. Right?
Okay.
And each one of these removes an x. So for every 2 powers of x, we can take out an x. So I've taken out 2 there. I'm going to take out 2 more, and I'm left with a root x. So this becomes x squared times root x. Okay? So I can put the root x, leave it under there, and put the x squared out there. So now I've covered this much of it. What's the square root of y to the 4th?
You can take 2 y's out, or you can take all the y's out. So it'd be just y squared.
Okay. And what do I do with this last z? Can I take any z's out? So I got to leave it in.
Okay.
And I can rewrite this. Okay. Now, another way to look at this problem is to rewrite it as entirely exponentials. Like that. And then that, of course, becomes x to the 5 halves, which becomes x squared times x to the 1 half, which becomes x squared times the square root of x.
Okay.
Okay? And this way sometimes is a little easier, especially when you get into cube roots or 4th roots or whatever. You can always make sure you come down to the right there, and then you just have to separate that into as many whole x's as I can take out of there, and whatever's left over.
Okay.
Okay, let's do B also. Right offhand, we got apples, oranges, and bananas. So I can't do anything yet.
Nope.
Until I can get them all converted into the same thing. So let's simplify some of these. What's the square root of 27 equal to?
Square root of 3 and square root of 9 should be 3 square root of 3.
Okay, so this is probably going to be our apple. So we're looking to turn everything into some number of square roots of 3, which is a hint as to how we should simplify that one.
All right.
In other words, for this to come down to some number of square roots of 3, how do we have to factor the 48?
Something times 3.
Well, what's 3 into 48?
They're 14.
16.
16.
So this is the square root of 16 times the square root of 3, which is 4 square roots of 3. Now we got apples and apples. We got to turn this one into an apple.
Okay. This should be 5 square root 3.
Now we can add and subtract them all.
This would be 2 square root 3.
Okay. What is C?
C.
How do you handle an exponent raised to another exponent?
You multiply.
Okay. So we have x to what?
3/6.
2/3 times 5/6.
5/6. Yeah, should be 10/18.
Okay, or 5/9. So the answer would be x to the 5/9.
Simplify. All right. Really.
Okay, let me see what else we got here. I think we have one more page. Yeah, I think it's this one. Yeah. This one's slightly different. Let's do at least one of these.
Okay.
What is f of g of x, first of all?
It's going to be...
Let's do it step by step. So what am I really taking f of?
3 over x minus 1.
Okay, and f of x is 3x minus 4. So f of 3 over x minus 1 would be what?
Sorry, say that again.
So what is f of 3 over x minus 1? Or what is f of g of x?
Would it be negative 12 over...
Well, let's do it. In other words, it's 3 times the quantity, 3 over x minus 1. This is the part I would like to hear you state so I know you're doing it right.
All right.
So that's 9 over x minus 1 minus 4.
Oh, okay. Okay, I see.
So that's f of g of x. Notice that they're not inverses of one another. We didn't get x. Yeah. If they were inverses of one another, we would have had to get x as an answer. We didn't. Okay. What's the domain of this function? First of all, what's the domain of f of x?
Negative 4.
No. Can x not be anything? Is there anything x can't be?
No.
So it's negative infinity to positive infinity.
Okay.
What's the domain of g of x?
It just can't...
Everything except what?
One.
Right. So negative infinity to 1 combined with 1 to positive infinity. Okay, so it's a different domain. Now what's the domain of this? What's the domain of the composite function?
It just can't be.
Same
be
thing,
anything, couldn't it?
except 1. Still can't be 1.
Because that wouldn't work out all
And
right.
not divide by 0. First commandment of mathematics. So you can never violate the domain. Okay, so it's the same domain as g of x. Now let's do the reverse, where if we start with this function and we substitute this, our domain stays with the original function. The original function has the most restrictive domain, so we can't violate that, no matter what. So g of f of x would still have a domain of can't be 1.
Yeah, because you can't divide by 0.
All right. Let's look at what is g of h of 2. Start from the inside and work your way out. What's h of 2?
One second. X.
Here's the h function. Here's the h function. What's h of 2?
Should be X.
Substitute 2 for x.
Oh, yeah. Just be 2.
Okay. So now when they say g of h of 2, they're really saying g of 2. It's g of 2.
So it would just be 3.
Uh-huh.
All right.
Just always work from the inside out. Okay. How about that equation?
One sec.
What's the first step here?
Square root, yeah, just square root 9.
We have to square both sides. Hold on 1 second, Alex.
Okay.
Hello? Hello? Max? Yeah, hi. 6:30. Or 6:20 actually. It was scheduled at 6:20. So I'll send you the meeting ID number here shortly. Okay? All right, bye-bye. Sorry about that.
Oh, that's all right.
Okay, so once you've isolated the radical, then the next step is to get rid of the radical. And the way we get rid of the radical is by squaring both sides. So when we square the left, we get this.
Yes.
What do we get when we square the right?
X squared plus by 9.
X squared plus 6x plus 9. X plus 3 times x plus 3 gives you a middle term.
Oh, square. Oh, yeah, right.
Okay? That's one of the more common mistakes in algebra, is to write that as x squared plus 9.
Okay.
Okay, so now what do we do next?
1 second. 6x plus. We just gotta solve for x, so I'd do, we could just subtract 9 from 10x. That would get rid of 9, so I'd just have 2x equals x squared plus 6x, and then minus the 6x, so I just have 4x equals x squared, and then square root both sides, so
No. What is this called? Where my check mark is? What kind of an equation is that? It's got a name. It starts with a Q. It's quadratic.
Oh.
How do you solve quadratics?
Whatever way. I do it the x.
Well, you put everything on one side and 0 on the other. Okay? So if I'm going to leave the x squared over there, I'll subtract the 10x, make minus 4x. The 9's still cancel. Now I can solve this. I can't solve this. I don't know how to solve that, but I can solve this. And I'll show you the difference here in a second, why I can't solve this.
Okay.
How do I solve it? You might think that you could divide both sides by x here, so that x would be equal to 4. But that actually isn't the right answer, or it's not the total answer. How do I solve this? How do I solve this quadratic?
You just factor.
Factor. You always factor. So how can I factor this? What can I factor out of that?
You can factor an x out.
Okay. So what we really have is x times x minus 4 is equal to 0. And now I've got two solutions. I got what?
Negative 4, or positive 4. And
what else makes this equal to 0? What other value of x?
Negative 4.
No. We're going to set either this equal to 0 or this equal to 0. Because we have the product of two things being equal to 0. Either one of them could be 0.
So just be 0.
Notice that 0 works just fine. I've got the square root of 9 equals 3. 4 works just fine. We got the square root of 49, which is 7, equals 7. So both of these are solutions. Now, let's go back to this method where you wanted to solve it this way.
Okay.
Might look like I could divide both sides by x. Problem is that whenever we divide both by a variable that might be 0, and if 0 is an answer, we'll lose that answer.
Okay.
We get x equals 4 only. We've completely lost the x equals 0 answer, which you would lose points for sure. If you put x equals 4 as the solution here, you're going to lose points.
I wouldn't even get the answer right.
No, you need both solutions, x equals 0 and x equals 4. So the thing to remember is that whenever you have a quadratic, put everything on one side, make sure 0's on the other, and then factor the quadratic into two things that are multiplied together. As long as, in other words, if I tell you x times x plus 1 is equal to 2, there's no way to solve that. But once I say it's equal to 0, well then either this has to be 0 or this has to be 0. The only way two things can multiply together to be 0 is if one of them is 0.
Yeah.
So that's the logic behind solving quadratics.
Okay, cool.
Okay. Let's look at a cubic. We've got cube root of x minus 3 plus 2 equals 4. First step?
Would I have to cube?
Not yet. Isolate the radical before you cube both sides.
So just minus 2.
Notice what happens if I try to cube it without moving the 2 over. I got to cube this whole thing, which is going to produce a bunch of middle terms.
Yeah.
That are still going to have radicals. So you can't cube both sides until you isolate the radical. So we got to subtract.
Okay.
So we got to subtract 2 from both sides. So now we have this. Now we can cube both sides. So what do we have now?
X minus 3.
Okay, we're cubing both sides.
Yeah, so it'd be 8 on that side, and then x squared.
No, this is no longer squared. In other words, when we cubed it, we lost the radical sign. That's all.
Yeah.
So x is equal to 11. And notice that works. You put in 11 here, you got the cube root of 8, which is 2. So 2 plus 2 equals 4.
Oh. Okay. Wow. All right.
All right.
That was a lot easier.
We better do one more of these. They get a little harder here each time. What's first step?
I gotta times by the...
Multiply both sides by 7.
Okay.
Now we have what's being taken to an exponent isolated. So now what?
And then I would distribute the
No.
properly. So.
Can't distribute. I don't know how to take x plus 9 to the 3/2 power. I could square it. I could cube it. But then I don't know how to take the square root of it, what I would have. So that's not how I get rid of this exponent. How can I get rid of the exponent? What do I have to do to both sides to get rid of the exponent?
I don't remember.
What if I take both sides to the 2/3 power? The reciprocal of this. Now I get rid of the exponent, because when you take an exponent to another exponent, you multiply them, this becomes 1. So I'm left with exactly x plus 9 on the left side of the equation, and this becomes, I don't know, what's the cube root of 343? That must be 7. So it's 7 squared. So this is 49. So x is equal to 40.
40. Okay.
So
that makes sense.
whether you have a square radical, a cube radical, or an exponent of 3/2, the way you get rid of that is just to multiply or to take each side of the equation to the reciprocal.
To the reciprocal. Okay.
To the reciprocal. In other words, if I had x to the 1/2 equals 4, that's the same thing as saying the square root of x equal 4. Well, how do I solve that? Normally we would say I would square both sides. What am I really doing? I'm really doing this.
Taking this, yeah.
I'm taking this to the reciprocal. 1/2 reciprocates to 2 over 1, and then that becomes x, and this becomes 16. Okay, I think I got to stop here.
Yeah, about 15. Yeah, we got.
What's the parent function on 10? That's the only thing I'll ask.
I'm just going to take a guess and say y equals 3 to the x plus 2.
Now close. Y equal 3 to the x.
Oh, just to the x.
That's the parent function. This plus 2 acts as a horizontal rotation, just a translation. That's all.
Okay. Oh, so it's, okay, so it's just...
Yeah, that plus 2 is a translation to the left of 2 units.
Okay.
Okay? All right. I will talk to you in a couple of weeks, I guess, huh?
Yeah, sounds good. Thank you for the help today. It was
Okay.
really helpful.
Good. Have a good one. Have a good spring
Yeah,
break.
you too.